Good day everyone, welcome back to our chemistry series, and today we'll be discussing the topic mole. Mole. The mole is the amount of substance that contains as many elementary entities as there are carbon atoms in 12 grams of carbon-12 isotope. Now, the number of atoms in one mole is known as Avogadro's number, which is given by 6.02 times 10 to the power of 23. Now, we're going to be looking at two formulas which we use for looking for mole. Now, the first states that a mole is equal to the mass in grams divided by the relative molecular mass of the substance we are looking for. And number of moles is equal to the number of particles divided by 6.02 times 10 to the power of 23. That's Avogadro's constant. So we'll be using these two formulas to do some calculation involving moles, Avogadro constant, and molecular mass and mass of substance given. Our very first example states that, so what is the mass of 5 mole of oxygen, O2, and the atomic mass of oxygen is 16. Now, for our solution, 1 mole of oxygen is actually O2 because oxygen is diatomic, so it will be the molecular mass of oxygen will be 16 times 2, which is equals to 32 gram. For our formula, n is equals to m divided by capital letter M, and we're given that n is equals to 5, that's our number of mole, and our molecular mass of oxygen, which is our capital letter M, is equals to 32. We are looking for our mass. So doing so, m will be equals to n times capital letter N. That if we cross multiply from the formula, n is equals to m over capital letter M. So small letter m will be equals to 5 times 32, which will make m to be equals to 160 gram. We have another example that states that how many atoms are present in 6.2 gram of magnesium. We are given 1 mole to be 6.02 times 10 to the power 23, and the atomic mass of magnesium to be 24. Now, for our solution, we know that our number of moles n is equals to the mass given all over our atomic mass, and substituting this will be 6.2 divided by 24, which will be equal to 0.258 moles. But we are looking for number of atoms, and we know that our mole is also equal to number of atoms divided by Avogadro's number, which is equal to number of atoms divided by 6.02 times 10 to the power of 23. Cross multiplying, number of moles will be equals to 0.258 times 6.02 times 10 to the power of 23, which is equals to 1.6 times 10 to the power of 23 atoms. We have another question from 2001 that states that a sheep used in a micrometer contains 5.72 times 10 to the power minus 3 gram of silicon. Calculate the number of silicon atoms in the sheep. We are given the atomic mass of silicon to be 28 and Avogadro's constant to be 6.02 times 10 to the power of 23 per mole. Now, for our solution, we are first going to be looking for our number of moles, which we are going to be using the formula moles is equals to mass divided by atomic mass. Now, substituting, this will be equals to 5.72 times 10 to the power minus 3 divided by 28, which will be equals to 2.04 times 10 to the power minus 4 moles. Now, for our number of atoms is equals to moles times 6.02 times 10 to the power 23. Substituting, it becomes 2.04 times 10 to the power minus 4 times 6.02 times 10 to the power of 23, which should be equals to 12.28 times 10 to the power of 19 atom, which is approximately 1.23 times 10 to the power of 20 atoms. We have another question that states that the mass of 1 mole of ammonium carbonate is, and we're given the atomic mass of all the elements. That's oxygen to be 16, nitrogen to be 14, carbon 12, and hydrogen 1. Now, for our solution, finding the mass of 1 mole, NH4 in bracket 2 CO3 is equals to N2, that's 2 nitrogen, H8 and CO3. Now, splitting this, it becomes N2 plus H8 plus C plus O3, and replacing them with the atomic masses, it will be equals to 14 times 2 in bracket plus 1 times 8 in bracket plus 12 plus 16 times 3 in bracket, which should be equals to 28 plus 8 plus 12 plus 48, which is equals to 96 gram. So 1 mole of ammonium carbonate is 96 gram. We have another question from 2017, and it states that the number of atoms present in 2.5 moles of triatomic gas is equivalent to Then in brackets, 1 mole is equals to 6.02 times 10 to the power of 23, and we're given the option. Now for our solution, we know that 1 mole is equivalent to 6.02 times 10 to the power of 23, and for a triatomic gas we have 3 atoms in 1 molecule. So 1 mole will be equals to 3 times 6.02 times 10 to the power of 23. Given that n is equal to the number of atoms divided by Avogadro's number, and substituting, 2.5 will be equals to number of atoms divided by 3 times 6.0 times 10 to the power of 23, and cross multiplying, number of atoms will be equals to 2.5 times 3 times 6.0 times 10 to the power of 23, which should be equals to 4.5 times 10 to the power of 24 atoms. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Fact Chemistry textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.